Hello dear students, I am Surendra Jain, Master Teacher of Mathematics in Vedantu. In this session, I am discussing high weightage test 21, most incorrect questions done by the student. This assignment, this high weightage test is based on straight line in 3D, in which we are taking a point in terms of parameter lambda. So let's see what are those questions. So the first question given is, the image of point 2i plus 2j minus k in the line passing through these 2 points. We have to find the image. So dear students, in this question we are given a line which is passing through these 2 points, and these 2 points are in position vector form. So I can write them in Cartesian form as 1 comma minus 1 comma 2, and for the second point it is 3 comma 1 comma minus 2. So the direction ratio of this line will become, if you take the difference of these two, it will be 2, 2 and minus 4. This can also be written after simplification because I can take 2 common. So 1 comma 1 comma minus 2. These are direction ratios. So it doesn't matter whether I choose this or I choose this. Now there is a point, let's say P, whose coordinate is given as 2 comma 2 comma minus 1. 2 comma 2 comma minus 1, and let's say its image Q is alpha, beta, gamma. So there are two things that we need to understand. One, that this PQ will be perpendicular to this line, and direction ratios of PQ not direction ratios of PQ would be, you take difference of alpha with 2, beta with 2 and gamma with minus 1, so it will become plus 1. Okay, now this direction ratio with this direction ratio, which is the direction ratios of this line, should be so that their dot becomes equal to 0 because these two are perpendicular. Okay, so taking the dot will give you alpha minus 2 plus beta minus 2 and minus 2 into gamma plus 1 is equal to 0. This gives you alpha plus beta minus 2 gamma, and minus 2 4. I think this will become equal to 6. So this is one equation that has to be satisfied for this Q being image of this point. Now another thing, the midpoint of P and Q for certain value of lambda. But before that, let me tell you, I can write the equation of this line in parametric form by x minus 1 upon 1 is equal to y plus 1 upon again 1 equal to z minus 2 upon minus 2. One very important form that is also called as parametric form, symmetric form of straight line in 3D. Passing through this point, so 1 minus 1, 2 will come in numerator with x, y and z, and the direction ratios 1, 1, minus 2 will be there in the denominator. Now we can take any point here. Let me call this point as M. Okay, so this point M we can take as, in terms of lambda, that will be lambda into 1 plus 1. So lambda plus 1 x coordinate. Similarly, lambda minus 1 y coordinate, and minus 2 lambda plus 2 as z coordinate. Now for certain value of lambda, midpoint of PQ should be equal to the point M, which means alpha plus 2 upon 2 should be equal to lambda plus 1. Alpha plus 2 upon 2 should be equal to lambda minus 1, and not alpha, this will be beta this time. And last, that gamma minus 1 by 2 will be equal to minus 2 lambda minus 2 lambda plus 2. Okay, now we can put the value of alpha, beta and gamma from here in this equation number 1, and that will give us the value of lambda. And using this lambda, we can say what will be the value of alpha, beta and gamma. Let me write this in terms of alpha. So this will become equal to 2 lambda plus 2 minus 2, so only 2 lambda. Beta will be equal to 2 lambda minus 2, so minus 2 4, and gamma will be equal to minus 4 lambda plus 4 plus 1, so 5. So these are the values of alpha, beta, gamma I am getting. Alpha will be equal to 2 lambda. Yeah, I think that's correct. Now coming to Now let's put these values of alpha, beta, gamma in this equation number 1. My equation number 1 is alpha plus beta, so 2 lambda plus 2 lambda and minus 2 gamma. So this will be minus 8 gamma with minus sign, one more minus sign, so it will become plus 8. So 2 plus 2 4, 4 plus 8, that means it will be 12 lambda. Okay, and the constant term would be here, this is 0 only, so minus 4 here, minus 4 minus 10, so minus 14, minus 14 going that side will be 20, will be 20. So we will be getting lambda to be equal to that will be 5 upon 3, we can say. Okay, now using this we can tell the value of alpha, beta and gamma. Alpha, beta and gamma. Alpha is 2 lambda, alpha is 2 lambda, so it will be 2 into 5, 10 upon 3, that will be alpha. Now you can see there is no option that is matching, so we can directly say answer will be none of these, but let me still find the coordinate of this point. So this coordinate will be 10 by 3 and then 10 by 3 minus 4, because lambda was 5 by 3, so 10 by 3 minus 4 will be minus 2 by 3, I think. And the last one is this gamma, that is minus 4 lambda plus 5, minus 4 lambda plus 5. So minus 4 lambda is minus 20 by 3 plus 5, yeah. So 20 by 3 plus 15. So I think 5 by 3, yeah, if I'm not wrong, that is the point, that is the final value of the image. 10 by 3 minus 2 by 3 and 5 by 3, actually minus 5 by 3, because that was minus 20 by 3 plus 15, yeah, so minus 5 by 3. So you can see the answer is D, none of these. And dear students, the calculation wise, I think this is the method. I think there is no other method to find the image. You may do slightly different variation in the calculation by taking, maybe some of you may say that I will be taking M as some point that divides this point to this point in some ratio 1:mu. Then your M will come in terms of mu, but it is exactly same thing as taking this M in terms of lambda. Here we are taking using symmetric form of straight line. There you will be taking M using section formula. It is same thing. Okay. Then again you have to take dot product equal to 0, and using that this M will be the midpoint of PQ. You will be solving for mu or lambda in my case. So that is how this question will be solved. Okay. This is one very important variety of questions. Please have enough practice on this kind of questions. Coming to the next question. Now this question says two lines are 1 and 2 intersect at point R. The reflection of R in the XY plane has coordinate. Now in such questions what we need to do, because this line, let's say L1, and this line, let's say L2, they are going to intersect each other. So I will take one point on this line and one point on this line in terms of lambda here and mu here, and then we will try to find out those values lambda and mu that makes both points to be same. Okay, this is one line, this is another line, and they are intersecting at this point. So this is my line L1, this is my line L2. Now on the line L1, if I equate this ratio equal to lambda, this point A, suppose that's the point of intersection, it will be lambda plus 3, lambda plus 3. This equal to lambda means x will be equal to lambda plus 3, and y coordinate will be 3 lambda minus 1, z coordinate will be minus lambda plus 6. Okay, now this has to be equal to one point on line L2, and this time I will take this in terms of mu. So 7 mu minus 5 minus 6 mu plus 2 and 4 mu plus 3. Now these 2 points should be equal to each other for certain value of lambda and mu. So I will equate these two, will give you lambda minus 7 mu is equal to minus 8 if I equate x coordinates. If I equate y coordinates, it will give you 3 lambda plus 6 mu, and that will be equal to 3. I think only 2 equations are sufficient to find the values of lambda and mu. Okay, third equation coming from z coordinate should automatically satisfy these values of lambda and mu. If it is not satisfying, then these lines will not be intersecting each other. You can call them as skew lines. That can be another way of finding whether lines are intersecting or skew. So here to solve it, I think I will multiply this by 3 and then I'll subtract this from this. So 3 into 7, 21, 6 minus 21, so 27 mu, and that will be equal to 27 only. 3 plus 24, 27. So mu is coming out to be 1 and lambda is coming out to be, if you put mu as 1, I think this is coming out to be -1. Let me check for the second equation also. So -3 plus 6, yeah, 3 only. So these are the values of lambda and mu we are getting. Now let's try to see whether we are getting same points by putting lambda and mu or not. So lambda, if it is -1, so this will be 2 for x coordinate, and if you put -1, this will be -4, and if you put -1, this will be 7 here. If you put mu as 1 here, so 7 minus 5, 2. If I put 1 here, so -6 plus 2, so -4, and 4 plus 3, 7. So they both are giving you same point. That means lines are actually intersecting. Now, if this is the coordinate of a point, let's say A, okay, and we are taking the image or reflection of this point in xy plane. Actually, they have called this point as R. Okay, so not A. This point is just R. Doesn't matter actually, but let me write it as R only. So if xy plane is given and there is a point above this xy plane, and if you take the reflection of that point in xy plane, only z coordinate will change, neither x will change nor y will change. So its image has to be 2 minus 4 minus 7. 2 minus 4 minus 7. So answer of this question should have been A. 2 minus 4 minus 7. Other options are all different. So A should be the answer of this question. Coming to this question, we are asked to find foot of perpendicular from 1, 2, 6 to the line x minus 3 upon 2 and so on. Now dear students, one very standard question. Here this point is 1, 2, 6 and you are dropping perpendicular from this to this line. Okay, now I can equate this equal to 0. Then this point will be 2 lambda plus 3, 2 lambda minus 1 and minus lambda plus 1. In fact, this will be A, this will be B, this will be C, as they have said, this point being ABC. Now, direction ratios of line joining P, and let me call this point as M, will be this minus this. So it will be 2 lambda plus 2, 2 lambda minus 3 and minus lambda minus 5, I think. Because lambda plus 1 minus 6 or minus lambda minus 5. Now this should be perpendicular to the direction ratios of this line, which is 2, 2, minus 1. Dear all, whenever you are copying these numbers written in the denominator, always make sure the coefficient of x, y and z are 1, 1, 1. Otherwise, they will not be qualified as direction ratios. So the dot product of this with this has to be equal to 0. So if you take the dot, I think 2 into 2, 4 lambda plus 4. Then again 2 into 2, 4 lambda minus 6 and minus 1. So it will be lambda plus 5, I think. And that is equal to 0. So 4 plus 1, 9 lambda. And here we are getting 4 plus 5, 9 minus 6, so plus 3 equal to 0. So the value of lambda will be minus 1 upon 3. Now we are asked to find the sum A plus B plus C. Now A plus B plus C is nothing but sum of x coordinate, y coordinate and z coordinate. So 2 plus 2, 3, 2 plus 2, 4, 4 minus 1, 3 lambda, and the constant term will be just 3 only. So the value of 3 lambda from this is minus 1. So minus 1 plus 3 will be 2. So answer of this question should be D. Yeah, answer of this question should be D. Coming to this question where we are given if the line this is hypotenuse of isosceles right angle triangle whose opposite vertex is 7, 2, 4, then which of the following is not equation of side of the triangle? Dear students, I will give you two methods for this question. Both are done by taking a point in terms of lambda. Please see how. First of all, let's make a diagram. So this is my right isosceles triangle. Okay, where this line is 5, 3, 8, and one of the point is -6, -10, -14 on this line, and the opposite vertex of this hypotenuse, that means the point where angle is 90 degree, is 7, 2, 4. Okay, so one method would be that you take this point on this line in terms of lambda, equate this to equal to lambda, so that will become 5 lambda minus 6, that will be 3 lambda minus 10, and this will be 8 lambda minus 40. Okay, now if we know this point, we can write the direction ratio of this side by subtracting these two. So it will be 5 lambda minus 13, then 3 lambda minus 12, and 8 lambda minus 18. This is the direction ratio of this side, and direction ratio of hypotenuse is already known, 538, and this angle is 45. Okay, so the angle between this direction ratio and this direction ratio is 45. Okay, or it could have been 135 also if we just take one of the direction. Like if you take both of them that way, it will be 45. If you take one of the direction like this and other like this, it can be 135 also. So we do not know, and also we have to take care of the other side also. Okay, so what I will do, I will write this angle being 45 or 135. So this cos of 45 or cos of 135, using that dot product, we will be getting plus or minus 1 upon root 2, and that has to be equal to the dot of this direction ratio with this upon their magnitudes. So if you multiply this with this, I think we will be getting this as 5 into 5, 25. Let me write first lambda terms. So 25 plus 9, 34, 34 plus 64, I think 98 lambda. Okay, taking dot of this direction ratio with this direction ratio. So 5 square 25 plus 9, 34, 34 plus 64 is 98. And the constant terms, minus 65, let me write them, minus 65, and 3 multiplied with 12, so 36. And this 8 multiplied with 18, I think it is 144. Okay, and divided by, in denominator, the magnitude of this will be 25 plus 9, 34 plus 8, 98, same thing here as we got here, and into under root of magnitude of this factor or this direction ratio. The coefficient of lambda square will be same, I think 98 lambda square. Okay, and then 2ab terms. 2ab terms means it will be minus 130. Let me write it here, minus 130 lambda from this 15, 5 into 13, 65, 65 into 2 is 130, and plus I'll take this sign, so this bracket, so 12 into 3, 36, 72, and 18 into 8 is 144, into 2 is 288 into lambda. Okay, and then plus, so this under root sign is actually continuing from here to here and then here also, and then 30 square is I think 169, plus 12 square is 144, and 18 square is 324. Okay, so what calculation we are getting here is this 1 upon root 2 with plus or minus sign equal to 98 lambda minus, this will become 36 plus 144 is 180, 180 plus 65 is I think 245. Okay, this is 98, and for this let's write the final thing now, 98 lambda square, and this will be, I think it is just double of this thing, so I can just make twice of this, so it will be 490 lambda. Okay, and this will be equal to, if I add these numbers, I think I have a calculation, so this will be 637. 637, you can check the calculation, 9 plus 4, 13 plus 4, 17, and then 1, 7 plus 4, 11 plus 2, 13, so 1 plus 1, 2, 3 plus 3, 6, yeah, 637. Now dear students, this root 2, let me do this calculation on the next page. After this, I'll use this space. Okay, so here this root 2 will cancel 98, I think, inside 49 times, that will become 7. Okay, so here it will be plus minus 1 is equal to, and now please understand very clearly, this term 98, this is also 98 into 5, and I think this is also 98, not 98, this is 49 into something. So if you divide this by 49, I think we will be getting here as 13. 13 into 49, if you check, is coming out to be this only. 13 into 9 is 117, 13 into 4 is 52, so 637. You may be feeling there is a calculation, but yes, in this method calculation is there. I will be telling you another method where you may have slightly lesser calculation but not much difference. This is also a good method, I will tell you, because then only I am doing it. Okay, because just do this calculation without error and you will get the value of lambda and then you are done. Okay, so what we will be getting, if I take 49 common from this, so 7 will come common from this and 7 will come from common from this, because this root 2 will cancel 98 as 49 inside this under root sign. So 7 from here and 7 from here. So what we will be getting here, this was plus minus 1. So if I divide this by 49, so this will be 2 lambda minus, if I divide this by 49, I think this is just 5 times, so this will be minus 5, and in the denominator this is gone because 7 is cancelled. Now this will be 2 lambda square and then 49. So 49 we have taken common, so 490 will become 10 lambda here. Okay, and then and this will be 13. This will be 13, so plus 13. So this is what we are getting. Now you just cross multiply it and you will be getting 2 lambda square minus 10 lambda plus 13 and squaring. So this will be 4 lambda square minus, I think, 20 minus 20 lambda plus 25. Okay, solving this will give you 2 lambda square minus 10 lambda and plus 12. So lambda square minus 5 lambda plus 6 equal to 0. So we are getting the values of lambda as 2 or 3. Now here lambda equal to 2 will be corresponding to one side and lambda is equal to 3 will be corresponding to other side. So if I take 2 for this thing, if I take lambda equal to 2 for this thing, okay, then putting 2 will give you 10 minus 13, so minus 3. 3 into 2, 6 minus 12, so minus 6. 8 into 2, 16 minus 18, so minus 2. So this is the direction ratio of this side, which you can write it as 3. Yeah, I think no changes you can make. You can just write 3, 6 and 2, nothing else. Okay, let us see if we are having one of the option like this or not. Actually, they are asking which of the following is not the equation of side of the triangle. So 362, yeah, 362 is one of the direction ratios, and the line passing through 724 is already given in the numerator. So this is actually the side, one of the side. So this will not be the answer. And similarly, if we do it for the other side, and that will be taken from the value of lambda equal to 3. So if you take lambda equal to 3, this direction ratio will be equal to 3 into 5. 15 minus 3, so 2, and 3 into 3, 9 minus 12, so minus 3, and 3 into 8 is 24 minus 6, or 6. So 2 minus 3, 6. So 2 minus 3, 6, and 7, 2, 4. So this is also one of the side. This is also one of the side. So the side that is not the line that is not the side of the triangle is C. You can see the point is same, but direction ratios are different. So C will be the answer of this question. Dear students, calculation was slightly more, but you can see if this question is made, with nice numbers, I will say, for final answer, I think your calculation will be such that numbers will cancel and you will be getting a nice value or simple values of lambda after simplification, after solving. So this is how you can do it. That is one method. Now I would like to tell you one more method of this question. Yeah. So the another method will be, I will not do the entire calculation, but you can do it. What I will be doing, I will be starting from this point 7 to 4, and I'll take foot of perpendicular from this point, let's say P, to this side M. Okay, and that can be found by taking a point on this line in terms of lambda or mu. Okay, so you can find this point M. Now in right angle triangle we have a property that midpoint of hypotenuse is at equal distance from all the three vertices. So these points will be having same distance from M as this point P is having. Knowing this thing and using the fact that if you take your direction ratios as direction cosines, okay, then this lambda directly gives you the distance. So using this distance PM, so on one side you will get this point using the same distance, and taking minus sign on that distance you will take another point on this side. So you will be getting this point as well as this point, and then you can write the direction ratios, and I think we are done. Okay, so what I said, start with P, take foot of perpendicular on this hypotenuse as M. Now PM, MQ, P, MR, all three distances will be equal. These three distances will be equal, MP, MQ, MR. Then write this line as a direction cosine in the denominator, not direction ratios, because if you put direction cosines here, okay, and you just need to divide by their magnitude, that's it. So if you take direction cosines here, then this lambda directly gives you the distance. Okay, but for that one more thing need to be taken care of. This point M has to be written with X, Y and Z here. Then after, if you take your point in terms of lambda and you take lambda equal to this distance, you will get one point Q here, and take minus of that same distance MP will give you point R there. Then the difference of these two will give you the line of line PQ and RP. Difference will give you actually direction ratios, and we know one of the point, so we will be able to get both the lines directly. So you can see this is also not very fast. The earlier one was bit faster because we just solved one equation. The only problem was that we were getting this 49, 98 factors, and that we have to do very carefully, because in exam pressure these numbers are not that easy to solve. Okay, so that is the method of this question 1 and then this 2. Coming to this question where we are given, find equation of line passing through 1, 1, 0 and intersecting these two lines. Okay, now when we have to solve, when we have to find intersecting line to two lines, the best approach in my opinion is you take one point on this line in terms of lambda, and take one point on this line in terms of, let's say, mu. So these two lines are, let's say, like this. These two may be skew, I do not know, so I will be making a general diagram here. Okay, so we are looking for that these 2 points, let's say one point on line 1 L1 and one point on line L2. Okay, and this is coming from this point 1, 1, 0. So we have to find the equation of this line passing through 1, 1, 0 and intersecting this line and this line. I can call this point as lambda plus 1, then 0, because 0 there in denominator of y, and lambda minus 1. So that will be the coordinate of this point. Let me call this point as A, this point as B, and then point on line L2 in terms of mu, it will be minus mu minus 1, comma 2 mu plus 2, comma that will be mu plus 1. Now dear students, now these 3 points should be in a line, and if they are in a line, then direction ratios of line joining A to P or direction ratio of line joining B to P, they should be proportional. So if I write for AP, it will be lambda plus 1 minus 1, so it will be lambda only, 0 minus 1, so minus 1, and minus lambda minus 1, minus 0, so minus lambda minus 1. Similarly for BP, if we write, it will be minus mu minus 1, minus 1, so it will become minus mu minus 2. Okay, and the other one would be 2 mu plus 2, 2 mu plus 2 minus 1. So 2 mu plus 1, and the last one will be mu plus 1. Mu plus 1. Okay. Now these three should be proportional. These three numbers of AP and these three numbers of BP, they should be proportional, and then we can find the values of lambda and mu. And how to solve it, let me do it on the next slide. Let me check my numbers. Lambda minus 1 minus lambda minus 1 minus mu minus 2 and 2 mu plus 1 mu plus 1. Now I will tell you one direct method to solve this, because some of you may think that it becomes very complicated to solve because we have to do cross multiplication and we get quadratic terms. If not quadratic, the terms where lambda and mu both are multiplied. Now today I will be telling you how you can avoid doing the multiplication and you can get the answer directly. So these are the ratios that we were looking for. Let me just check these numbers are correct or not. So lambda minus 1 minus lambda minus 1, lambda minus 1 minus lambda minus 1, and for mu it is minus mu minus 2, 2 mu plus 1 minus mu minus 2, and 2 mu plus 1 and mu plus 1. Okay. Now dear students, to solve this, what we will be doing, we will be using ratio and proportion law. What is ratio and proportion law? Because these three numbers, these three ratios are equal. So if I add any two ratios such that numerator is added with numerator and denominator is added with denominator, will give you same ratio. So here I will choose this to be added with this. So lambda minus lambda 0. So it will be just minus 1 here. And for that you have to add denominator also. So minus mu plus mu 0. So minus 2 minus 1. So minus 1. So finally it is coming out to be 1. Which means if I now use this equal to 1, okay, so 2 mu plus 1 will be minus 1. So the value of mu will be equal to minus 1. So we have got value of mu as minus 1, and putting mu as minus 1, we can find lambda also. But I feel only mu is sufficient to find. Why not? Because if we know mu, I think we have got the direction ratio of this line, and already this point 1 comma 1 comma 0 is known to us. Okay, so in this, from the next slide we got lambda, not lambda, mu equal to minus 1. Okay, so the direction ratio of this line has to be minus 3 minus 1 if I put it here. So plus 1 minus 2, so minus 1 actually, and minus 1 if you put it here, so this will be again minus 1 and that will be 0. You can write this as 1 comma 1 comma 0 also. Now dear students, the equation of this line PAB in vector form, because this point is lying on the line, so it will be I plus j. So this option A is wrong, I plus j plus lambda times I plus j. So B is correct. This vector here tells you the position vector of the point lying on the line, and lambda multiplied with a vector, so this vector gives you the direction or direction ratio you can say of the line, so which is 1 comma 1 comma 0. So B is the answer. All other answers are wrong. Here direction ratios of this is also same as this, but this point is not lying on this line. You can check because if you want this point also lying on this line, you can see your lambda has to be 0 for x coordinate to be matching. But if lambda becomes 0, your y coordinate will be j, it cannot be minus j. So A is wrong, B is correct, and here C and D are definitely wrong because their direction ratios are also not matching. So answer of this question should be only B. Okay, so what I have done, you can just go through once again. I took two direction ratios, PA, PB, and then I compared them by taking the ratio. And the very important thing here was this ratio proportion law. Otherwise, what you people are doing, you cross multiply them and solve them. It's a very big task. Don't do that. Just do that ratio proportion law, and you can do it. Let me tell you the reason why we are doing it. Now tell me one thing, suppose there are fractions and now I am writing with numbers. So one is 1 upon 2, one is 3 upon 6, and one is, let's say, 5 upon 10. Now can we not do this thing that we add these two? So 1 plus 5, 6, and we add these two, 12. So 6 upon 12 will also be 1 upon 2. Now you can do it in multiple ways. You can do one more thing. You multiply this by some number, let's say A, and you multiply this by number B. So it will be A plus 3B here. upon same number you have to multiply in the denominator, so 2a plus 6b, and you can check after simplification it is also coming out to be 1 upon 2. So for our convenience we are multiplying numerator and denominator by any number of our convenience. I think 0 should be avoided, because if we are multiplying here and here, it will not serve any purpose, although it is not wrong, but it will not serve any purpose. So this is what I have used it. This kind of questions, whenever you see, you will feel the need of this ratio proportion. Coming to this question, find equation of a line which passes through the point 1, 1, 1 and intersect the line this and this. Now to do this question, these two lines I am assuming they are skew lines, and 2 points on them joined are coming from 1, 1, 1. I think we are looking for the equation of this line PAB, the equation of line which passes through 1, 1, 1 and intersect the lines, let's say L1 this and L2 this, and we have to find the equation of this PAB. Now I will be taking a point on this line L1 which will be 2 lambda plus 1 and 3 lambda plus 2 comma 4 lambda plus 3. And this point B I can take in terms of mu. So mu minus 2, 2 mu plus 3 and 4 mu minus 1. So these are the points that we have got. Now if these 3 points are in a line, we need to ensure that direction ratios of PA and PB has to be proportional. Okay, which means direction ratio of AP, if I write, it will be 2 lambda minus 1, so 2 lambda, then 3 lambda plus 1 and 4 lambda plus 2. So that is the direction ratios of AP. This minus 1, this minus 1, this minus 1. Yeah, correct. Okay. Now similarly we will do it for BP. The direction ratios would be mu minus 3 and 2 mu plus 2 and 4 mu minus 2. Now the ratio of these has to be same. So we will be getting 2 lambda upon mu minus 3 is equal to 3 lambda plus 1 upon 2 mu plus 2, and that is equal to 4 lambda plus 2 divided by 4 mu minus 2. Now if you start cross multiplying these, it will become very, very difficult. What I will be doing, I will be using ratio proportion. Ratio proportion means I will be writing these ratios to be equal to, after multiplying this with some number, multiplying with this with some number, this with some number, and then adding them in numerator as well as in denominator. Now so I will be doing one thing first. I will try to eliminate lambda. So what I can do, I can multiply this by 3, I can multiply this by 2 and then subtract this by 3, this by 2 and subtract. So here in numerator it will be just 2, because 2 into 3 6, lambda minus 6 lambda 0, and 1 into 2 2 here. So I multiplied this by 2, so 2 into 2 4, 4 minus 3, so it will become mu here. Okay, if I multiply this by 2, so 2 into 2 4 and 4 plus 9, so it will be 13. 4 plus 9 is 13. Yeah, correct. Now I will do one more time the similar thing. For this time I will be doing it for first and this third one. I will multiply this by 2 and subtract this from this, so it will be 2 here, and you multiply this by 2 and subtract from here, so it will be 2 mu and minus 2 plus 6, so it will be plus 4 here. Now you just have to solve this. To solve this means 2 gets cancelled, so mu will be equal to, I think mu will be equal to, this mu will go this side and 4 will come this side, so mu will be equal to 9. I think that much is sufficient to solve this question, because if I know mu, I think we can find the direction ratio of this line using BP also. Okay, so this BP, the direction ratio of this BP will be, if you put lambda mu as 9, so 9 minus 3 is 6, and 9 into 2 18 plus 2 20, and 9 into 4 36 minus 2 is 34, I think. Yeah, or you can write this as, after simplification, 3 10 and 17. So that's it, because we already know 1 point and we have got the direction ratios, so nothing else is needed to be done. So what should be the line? We got 3 10 17. So 3 10 17, 3 10 17 are there in 2 options, but this passing through 1 1 1, so this A should be correct. Dear students, there is one catch, please try to understand, because this is maybe single correct question, but if it is multiple correct, then you have to check for this point, this line also, because this line is having 3 10 17 same direction ratios as the answer. But who knows, this point minus 1 minus 1 minus 1 is also lying on the same line, then this will also be considered as a answer. But here you can see 1 1 1 is definitely the point lying on this line. If we consider this as an answer, this minus 1 minus 1 minus 1 should also lie on this line. But if you take the difference of 1 1 1 and minus 1 minus 1 minus 1, the difference will be 2 2 2, or you can say 1 1 1 in simplified form. So if these 2 points are lying on the same line, their direction ratio should be 1 1 1 and not 3 10 17. So that means this B is wrong. Okay, now you can go ahead and you can mark your answer as A for sure. Coming to this question where we are given M is the foot of perpendicular of point P in the line, then direction ratios of PM are. Okay, so here M is foot of perpendicular of the point 3, 5 and 7 in the line. I can take this point M as 5 lambda plus 7, 7 lambda plus 3 and 3 lambda plus 5. Okay, now if this A, B, C are equal to this, this and this, now condition of foot of perpendicular should be the direction ratio of line joining this P to M, which would be 5 lambda plus 7 minus 3. So it will be 5 lambda plus 4, 7 lambda minus 2 and 3 lambda minus 2. 3 lambda plus 5 minus 7, so 3 lambda minus 2. So this will be the direction ratio of PM, and the direction ratio of this line are already given 5 7 3. Before you conclude these 5 7 3 as direction ratios, make sure that coefficient of x y z are 1 1 1. In some questions they deliberately give you like 5 minus z or 3 minus 2y, so you have to make them 1 1 1, then only take them as direction ratios. Now the dot product of these two, this with this, has to be 0. So if I just consider lambdas first, so 25 lambda plus 49 lambda, 74, 74 plus 9, 74 plus 9 is how much? 83. Yeah, 83 lambda here. And if I consider the constant terms of 4 plus 4 into 5 is 20, and minus 14 minus 6 is equal to 0. I think this is also 0, so the value of lambda is coming out to be 0. What does this tells you? If they are saying lambda is equal to 0, this means the point they have written on the line in the equation of line, that is 7 comma 3 comma 5. 7 comma 3 comma 5 itself is the foot of perpendicular. Okay, they are asking the direction ratios of PM, so lambda become 5. So direction ratios, that means my final answer should be 4 minus 2 minus 2. You can simplify also this after dividing by 2. Let me see in what form they have given the answer. So yeah, so 2 minus 1 minus 1, 2 minus 1 minus 1 is the answer. So A should be the answer. You have to divide by 2. It's direction ratios, so we can always divide by some non-zero numbers to get new direction ratios. Still they will be representing same direction. Okay, so that's it for this session. Thank you so much. Bye bachcho, take care.